So hello all, good evening. Welcome back to this sessions of engineering mathematics. I hope all of you are doing good. So please confirm the audio and video once. Hi all of you. Yeah, good evening. So please type in the chat box, is the audio and video clear to all of you? Yes? Yeah, great. Okay, I hope it's clear. Okay. Yeah, it's clear, right? Great. So even I'm very much happy to restart this sessions, basically engineering mathematics. Okay, so sometime back we have started, but again due to the clash with other technical subjects, we have slightly put it on hold for some time. But now we'll try to again go to some distance in this particular topics. Okay, so daily again we'll get back and we'll be starting the class at 7 p.m. of course, and this series is basically like the continuation of what happened in the past. Okay, so in the last lectures we have looked at linear algebra, and after linear algebra we have started single variable calculus, where I have given idea up to the mean value theorems. Actually, if you have followed thoroughly and if you have revised the things well, so you would be able to solve till the mean value theorems of single variable calculus. Okay, so in this particular series I'm going to start from the continuation, which is basically the Taylor series. Okay, and let's see. So this is 2.0 lecture number 1, which is basically the continuation of the past lectures actually. Okay, and of course, you know, basically this is the Wallah English Telegram channel link. So any update regarding the events on this channel is being posted here. So if you scan this code, it directs you back to the Telegram channel of Wallah English, and this is when I basically my Telegram ID. So if you want to get in touch with the student or the student community of us, you can just scan this code so that you can have a chat with me if you want. Okay, regarding any things. Then obviously if you install this Unity, you will be having a track of all the polls at a particular instant or at a single location. So please do install this Unity app, and once you sign in up, this future site like something like this. Okay, so where you have the complete dashboard of yourself and your poll accuracy, the locations where you are committing mistakes. So all these things will be available at a single spot, of course. Okay, so just log into this Unity, of course, and this is how basically the dashboard. And before you enter your doubt, if you type exclamation doubt and then enter your doubt, it gets saved here. Okay, so in the doubts and also in the notes, whatever you have here. Okay, so please, when you ask any doubt, or if you feel that this doubt will be helpful in the long time, so in the chat box before you type your doubt, please type an exclamation doubt and then type your doubt, of course. Okay, so can I write get only from XE? Yeah, of course. Okay, and basically I would like to give a quick review of what happened in the past, because it's been quite some gap actually. So let's start in the single variable calculus. In the single variable calculus, we have talked about limits. Okay, so we have talked about limits, of course. Then we have seen things about continuity and differentiation. Continuity and differentiation. So I have given you basically the first principle of differentiation. So if you have any function, the derivative of this is calculated using this h tends to 0 f of x plus h minus f of x divided by h, of course. Or else if you want this derivative at a particular point x is equal to a, then this is limit x tends to a f of x minus f of a divided by x minus a. And I hope all of you remember these things, because we have shown with the help of the graphs each and everything. Okay, then we have also seen some standard graphs which we'll keep using up in the upcoming sessions. So some standard graphs actually here, and then we have also seen the applications of this differentiation, which is the first application, which is of course the mean value theorems. Okay, so the mean value theorems. And if you remember, in the last class I have closed up with LMVT, which is the Lagrange's mean value theorem, which tells you if f of x is continuous in a comma b and differentiable in open interval a comma b, then definitely there exists C belongs to a comma b, and such that f dash of c is equal to f of b minus f of a divided by b minus a, of course. Okay, so these are the things which I have taught basically in a broader sense in the last lecture. Okay, so do you all have the idea till this point? Yes or no? because in the last time series when I have stopped, basically we have stopped at this particular point of Lagrange's mean value theorem actually. So can you all recollect this? Yes or no? Please type in the chat box. Have you all revised these things or just left after the course was done? So let me check whether you have done these questions or not. Basically when you have revised this or not, let me give you a poll. So before I start teaching, I'll start with a poll actually. So all of you please solve this question. That tells you how well you have revised the things. Come on. So I'm giving you some 120 seconds in order to solve that. Okay. So start the poll. Come on, do that question. Limit x tends to 1 minus e power minus c times of 1 minus x by 1 by x 1 minus x into e power minus c of 1 minus x. Come on, do this question. I've started with a poll because I want to check whether you are in touch with the subject or not. Come on, do this. The value of this particular limit. Ashwini Kumar Biswal, C, maybe, hopefully. Everyone, please type in the chat box, okay? I mean, you can enter in the poll is active. The time is running up fast. If you have practiced enough, if you are doing the revision, you would answer this question, definitely. Come on, do this. Option C is what you feel. Okay, fine. Maybe, hopefully correct. Everyone, see, hi, Sagnika, Arvind, Gaurav, Vijay, reviews. Yeah. Okay, so let's see. Quick, faster. Okay. So do it quickly. Okay, Sagnika, you want to say C? Fine. Let's see. Fine. Okay. So let's solve this question. Limit x tends to 1 minus e power minus c times of 1 minus x divided by 1 minus x into e power minus c times of 1 minus x actually here. Okay. So this question is asked here. Actually, this question came in one of the mechanical papers, okay, around 2020, I think. So this question was asked in mechanical papers. The reason why it was asked in mechanical engineering paper, I'll tell you. But first, let us solve this question mathematically, okay. So if you replace x is equal to 1, this becomes 1 minus e power minus c into 1 minus 1 divided by 1 minus 1 into e power minus c of 1 minus 1. So this is 0 by 0 form clearly, correct? Because 1 minus 1 is 0, so e power 0 is 1, so 1 minus 1 is going to be 0. Similarly here, this is also 1 minus 1, which is again 0, of course, okay. So now we can apply L'Hospital rule. So applying L'Hospital rule actually. So applying L'Hospital rule. So let's see, this is equal to limit x tends to 1. Then if you apply L'Hospital rule, the derivative of 1 is 0 minus derivative of this term. So exponential derivative is exponential itself into the inner derivative of this term, which is plus c, of course. Okay, so we have a c here because you can see minus c into derivative of minus x is minus 1. So minus c into minus 1 is plus c, of course. Okay, and coming to the denominator, because denominator is a bit large. So let's see, differentiation of 1 is 0 minus, then it is product of two functions. So first function into the derivative of the second function, which is e power minus c times of 1 minus x into c plus e power minus c times of 1 minus x into the derivative of x with respect to x is 1 actually here. Okay, so that's what we have. Then let us cancel this term, which is in common in each and every term. So this term will actually get cancelled up, and this plus this minus and this minus cancels up. So you have eventually limit x tends to 1 c upon c into x, so which is cx plus 1 actually. So when you replace x is equal to 1, this is c by c plus 1 actually here. Okay, so that's how the limit value is, of course, c by c plus 1, which you have in option C. Okay. Now the reason why this came in mechanical paper, anyone from mechanical engineering here? Chemical, mechanical or chemical? Anyone from mechanical or chemical here? Quick. This question has actually come up in the mechanical question paper. The reason why it was given in the mechanical paper is because, anyone from mechanical? No. Okay, fine. So yeah, you have people from mechanical, right? Okay, good. So let's see. Many of you might have studied something called parallel flow heat exchanger. Correct? Parallel flow heat exchangers. So when you have studied this parallel flow heat exchanger, ultimately the formula for effectiveness is e power minus, sorry, it's a counter flow. Sorry, it's not parallel flow expression. This is for counter flow. So counter flow heat exchanger. So for counter flow heat exchanger, you might have seen 1 minus e power minus NTU times of 1 minus C by 1 minus C into e power minus NTU times of 1 minus C actually here, where C is C capital min by capital C max, which is the heat capacity ratio actually. Okay, and when these are heat capacity ratios and NTU is the number of transfer units, when the heat exchanger is having the ratio to be 1. Okay, so let's say if both the fluid, or basically if the mass flow rate into specific heat term is constant, and if this value is tending to 1, you might have studied this effectiveness of the heat exchanger falls to be NTU by 1 plus NTU. Have you studied this? Yes or no? Normally in the case of counter flow heat exchanger. So please type this in the chat box. Meanwhile, there is some question. So in continuity of a function f of x at x equal to a, you said f of a is equal to limit 2. You have put point a comma f of a above the function. How the point comes, and it is discontinuous point and makes the function continuous. Yeah, got it. See, basically, I'll tell you. I got your doubt. So first of all, please confirm. Is this clear to all of you? Whoever is from mechanical, I hope they might have understood this. So normally in the case of counter flow heat exchanger, the effectiveness of the heat exchanger is given by this expression, and this is exactly this, whatever they have given. Okay, C is the constant, which is NTU here, they have given, and this x is tending to 1. So the heat ratio is tending to 1, then the effectiveness turns to NTU by 1 plus NTU, which is basically this answer. Okay, now coming to your question, Arvind, look, basically I have done, if this is the function which is discontinuous, then we have taken the split function here and we have designated this as f of a. Okay, and this is x is equal to a, and this is L of course. Now to make this function continuous, if this point comes and settle here in this case, then ultimately the function becomes smooth and continuous. Okay, so when this function will become smooth, when this point actually settles here, and this point geometrically settling here is mathematically same as this f of a becoming equal to L. That's how the functional value and the limit are equal in that case. Okay, that's the. Now let me give you one more question. Okay, so okay, before solving this question, I want to give you one more question actually. Okay, so let's see what we shall do. So JEE Advanced 2024. Okay, just a minute. Okay, so JEE Advanced 2024. So let's see, we have the question papers, of course. I just want to give you one question. So 2024 question paper and final answer keys. Okay, so paper 1, responses, registration. So paper 1, so let's say paper 1 for example. So this is a very small limit, of course, issue. Now I want to give you one limit actually, which was a numerical answer type question that was given in this particular year. Okay, so it's not here, so maybe paper 2. Let's go for paper 2 actually, because you know we have got enough concept, so we can actually solve the question. Yeah, good, this question. So please solve this question. So what we can do is limit x tends to 0 plus, the question what I'm writing is the value of k for which limit x tends to 0 plus, of course, so in the right neighborhood. Okay, so x tends to 0 plus sine of sine kx, sine of sine kx, this term, plus sine of sine kx plus cos x plus x, cos x plus x whole power, so cos x plus x whole power 2 by x is equal to, so this is 2 by x is equal to e power 6. Okay, so this e power 6 is the value. Then what is the value of k? So basically the value of k, if this limit is valid, where k belongs to real numbers, of course. Okay, so k belongs to real numbers, is dash. So the answer is an integer. So I give you 2 minutes time, because this doesn't take more than 2 minutes. It's advanced question, but of course, yeah, in the previous case, all of you have answered correct. Good. So let's solve this question. Integer type. I'm giving you, okay, 2 minutes. That's it. Okay. So solve. Enter the answer. Because if you have revised limits, then this question would also have been a good practice. So please do this question. It's a question from JEE Advanced this year, but of course, a very simple question. The value of k for which this limit is equal to e power 6 is dash. Quick, faster. Okay, is 0 maybe, because it's an integer. That's all I know as of now. But of course, it's a very easy question. In fact, you can do. Come on, be quick, a bit faster. Your calculation speed should not go down. Okay. Fast, only 2 minutes, so 1.5 minutes, hardly 1 minute left. K is 2 maybe, no idea. Let's see. Let's check what's the value of k. It's coming out to be 2, possible, because it should be an integer actually. Last 30 seconds kind of thing. Come on guys, do it a bit fast. Okay. So the time is rolling up. Fine. So let's see. Solution. So let's solve this question. So given limit x tends to 0 plus x tends to 0 plus sin x or sin power sin kx plus cos x plus x, this whole value per 2 by x is equal to e power 6. Now tell me one thing, can I write it as, okay, so what is the answer? 2, you are getting 2. Okay, fine. So let's see, can I write this as this 2? Okay, so this is the limit actually, which is e power 6, but in general, if you don't take this e power 6 and if you calculate the limit, let's see, this tells you if you put x equal to 0 here, then sin 0 is 0, then sin 0 is again 0, cos 0 is 1, 1 plus 0. So this total expression base is 1, and since x tends to 0 plus, this tends to infinity, so this value turns out to be 1 power infinity form, right? So if you are having 1 power infinity, so I have told you, if limit x tends to a, f of x per g of x is giving you the form 1 power infinity, then this limit x tends to a, f of x per g of x can be calculated using exponential of, or basically e power, you can say, limit x tends to a, g of x times of f of x minus 1 actually here, correct? So that's the value what you have. Now let's see, hi Vamsi. So if you simplify this, let's see what happens. So therefore, limit x tends to 0 plus sin of sin kx plus cos x plus x whole power 2 by x. So since it's clearly giving you the form 1 power infinity, you can write it as e power limit x tends to 0 plus, okay, e power x tends to 0 plus g of x, which is 2 by x, into f of x minus 1. So sin of sin kx plus cos x plus x minus 1 obviously here. Okay, so this is what you have. Now ultimately this limit is something like, so this value is equal to e power 6. So this is equal to e power 6. So what does this tells you actually? So this implies ultimately the power on the top of e, limit x tends to 0 plus 2 times of sin kx plus cos x plus x minus 1 is equal to e power 6. So this, basically since exponent we have neglected, this is 6 on both sides, because if bases are equal then exponents should be equal. So that's what you have. So this is equal to 6. So ultimately this 2 is a constant which can cancel this 3 times, of course. Okay, now if you calculate this limit, so let's see what you'll get. X tends to by x is also there, sorry, this 2 by x. So here you have a division with x in this case. Okay, so this is x. Now if you again put 0 plus here, this is 0 1 0, so this complete expression is 1. So 1 minus 1 is 0, and this is also 0. Okay, so it's again giving you 0 by 0 form, but it should be a finite value. So let's apply L'Hospital rule again. So therefore limit x tends to 0 plus, now what about this limit? Derivative of sine is cos times sine kx into inner derivative. So derivative of sine cos kx is cos kx into the inner derivative of x kx is k. Okay, that's the derivative of this term, plus derivative of cos x minus sin x plus 1, that's the differentiation of this term, divided by 1, of course. Okay, so this divided by 1 actually here, so this divided by 1 is equal to 3. That's what you have. So if you place x is equal to 0, this implies, so if you will place x is equal to 0, then sin 0 is 0, so cos 0 is 1 into this is also 1 into this is k, of course, minus sin 0 is 0 plus 1 is equal to 3. So ultimately k is equal to 3 minus 1, which is equal to 2. So therefore k value is equal to 2. Just apply L'Hospital twice, you will get the answer simply. Okay, so k value is equal to 2, of course. Okay, k is equal to 2 in this particular case, so 2 is the actual correct answer. Okay, so k is equal to 2. Let us check the answer. So option B, answer is option B, k is equal to 2. That's it. Okay, it's a simple question that can that came here. So first year students can watch. Yeah, of course you can do that. So let's see. So basically these are the questions. Now I would like to give you one more question, but after some time. Okay, so let us start Taylor series, then we shall move forward. Okay, so in this lecture basically I'm going to focus on Taylor series and also the concept of maxima and minima of a single variable actually. Okay, so first let us start with the Taylor series. So Taylor series tells you if you have any function which is continuous and differentiable, of course, at any given point, then how to expand that function in the coefficients of x minus a. Of course we are talking about single variable here. Then when we move to multivariable calculus, the next module, I'll talk about the Taylor series in 2 variables actually. Okay, so Taylor series for a single variable function, at this case for a single variable function. So let's see, if you have a single variable function, if f of x is continuously differentiable, if f of x is continuously differentiable at a point x is equal to a, then the Taylor series expansion, the Taylor series expansion of f of x about x is equal to a is given by f of x is equal to, so this is how you expand the Taylor series, f of a plus x minus a into f dash of a by 1 factorial plus x minus a whole square times f double dash of a by 2 factorial plus x minus a whole cube into f triple dash of a by 3 factorial, and so on, it goes to infinity actually here. Okay, so this is infinity. So we can apply in both sides. Where in the previous question, means basically in the previous limit calculations, right? Yeah, we can apply. Basically you can apply in the numerator and as well as denominator. Once you know this point, this is step number 1, what you will do obviously, and this is step number 2. That's it. Okay, in 2 steps you'll get the answer. Hardly takes 2 minutes. Then let's see. So in this particular case of Taylor series, can you tell me the coefficient of x minus a whole power n is nth derivative of f at a divided by n factorial. Okay, so this is the coefficient of the Taylor series. And tell me one thing, if you are talking about x tends to a, about x is equal to a, so it's almost like x is tending to a, then when x is tending to a, when x tends to a, this implies x minus a whole square by 2 factorial, or x minus a whole square. Can someone tell me what this value tends to? If x is tending to a, the difference between x and a is very, very small. So let's say of the order 10 power minus 8, for example. Okay, then if you take the higher order terms, okay, so x minus a whole square, in all these cases, what happens to this value? What is the value of x minus a whole square when x is tending to a? Come on, quick. When x is moving towards a, what is the approximation of x minus a whole square? The value tends to 0, right? So this value tends to 0. And of course, there could be few special cases where these functional values are very large, they go to infinity and all, but we are not going into that cases. We are dealing about the smooth functions, okay, which are continuous and differentiable continuously. So let's see. Then this implies x minus a whole square by 2 factorial, x minus a whole cube by 3 factorial. All these things will tend to 0, of course. Okay, so because 2 factorial is like 2, then 3 factorial is 6 again. Okay, so these things divide with a higher numbers, and obviously that results will go to 0 actually. So therefore we define something called linear approximation of Taylor series. Linear approximation of Taylor series actually. Okay, so linear approximation of Taylor series. So how do we linearly approximate the Taylor series? Let's see. So f of x is equal to, as the name tells you, you take the terms only up to the first degree. So x minus a whole power 1 into f dash of a by 1 factorial. That's it. Okay, the reason why this happens is because when x is moving towards a, very close to a, the value of x minus a whole square, x minus a whole cube, these terms tend to 0 very fastly, and obviously this is the linear approximation which you get, of course. Similarly, if you have a quadratic approximation, if you want higher accuracy, sometimes you go for quadratic approximation. Quadratic approximation. So this tells you f of x is equal to f of a plus x minus a times f dash of a by 1 factorial plus x minus a whole square times f double dash of a by 2 factorial. That's it. Okay, so we are truncating here because we want the terms only up to the quadratic degree, which is the second degree actually here. Okay, so x minus a whole square times f double dash of a divided by 2 factorial. Okay, now let's see one thing. This is when you're having the expression about x is equal to a. Okay, so in general, for the expansion to have terms only of x, for the expansion to have only powers of x, or powers of x alone, to have powers of x alone, can someone tell me, if instead of x minus a whole square, these terms, if you want to have only x minus a whole square, or basically if you want to have only x square, what should be the value of a? Can anyone tell me what should be the value of a, so that in this expansion, or basically in this particular expansion, you have only terms like x into f dash of something, x minus x square. There is no x minus a term, it's like purely in terms of x. Then can someone tell me what should be the value of a here? If this term want to become x square, then what should be the value of a? Quick, a bit fast. 0, right? A equal to 0. So x alone, the Taylor series expansion, should be about a is equal to 0, and that series is called, Maclaurin series. Okay, so that's called basically the Maclaurin series. So that's basically the Maclaurin series. Okay, yeah, of course, the expansion has to be about a equal to 0. So any Taylor series expansion about a equal to 0 is called as the Maclaurin series. Okay, in few books you find it the other way. The Taylor series expansion, the general Taylor series expansion expansion is given as f of x plus h is equal to f of x plus h into f dash of x by 1 factorial plus h square by 2 factorial into f double dash of x plus h cube by 3 factorial into f triple dash of x and so on. Okay, so this sequence, or basically this series what we have, and the series what I have given you here, basically this series both are same. Okay, because you might have remembered when I'm talking about the general expansions, we have taken the points on x-axis to be x plus h comma x. Okay, and in the second case we have taken the points to be x equal to a and x equal to x, the general coordinate. Okay, so in general, if you observe this x minus a, the small difference, we have taken it as x. Yes or no? Do you remember this? Can you all recollect this? This x minus a difference is what we have taken as h. So when h tends to 0, this automatically implies x tends to a. Correct? We have done these things basically in the calculation of differentiations. Okay, when I have given the principle of differentiation, then I have explained you both the formulas, of course. Okay, so if you replace this h with x minus a, then obviously this is something like x minus a by 1 factorial into f dash of a minus h, but h is again very small, so h is this x is a plus h, of course. So this h is tending to 0, so obviously this terms becomes f dash of a, f double dash of a, f triple dash of a, all these things. Okay, so in general, this is the general expansion of the Taylor series, and even if you write at a particular point a, x equal to a, then this is how you have the Taylor series expansion here. Okay, now let's see. So let's understand certain things. Like for example, say the expansion of sin x, the expansion of f of x is equal to sin x about the point x equal to 0. Let's say about the point x is equal to 0. So let's say you want terms containing only x. Okay, there is no need of any x minus a term. We need only the sin x expansion in terms of x alone. Okay, so if you need this, what we can do? Look, so we have f of x is equal to f of a, or in general I would like to just write it in the summation form, n equal to 0 to infinity, n equal to 0 to infinity. So x minus a whole power n into nth derivative of a by n factorial. Okay, so this is what we can write. If you expand this obviously from 0 to infinity, then this term, of course, this is the same expansion as the previous expansion. So if you put n equal to 0, x minus a whole power 0, 1 into 0th derivative of f of a. So the f of a itself by 0 factorial, which is 1, plus when n is equal to 1, x minus a into first derivative of f at x equal to a by 1 factorial, and so on. This goes up to infinity. It's a infinitely extending series. Okay, so here what they are asking about the point x is equal to 0. So which means this a value is 0 in this case. Okay, so a is 0, of course. So if a is equal to 0, then you have f of x is equal to f of 0 plus x into f dash of 0 by 1 factorial plus x square into f double dash of 0 by 2 factorial plus x cube f triple dash of 0 by 3 factorial plus x power 4, fourth derivative of 0 by 4 factorial, and so on. This sequence goes up. Okay, but now you can understand something. This function is sin x, it's a repeating function. So if you have sin x, then ultimately this implies f dash of x is cos x, f double dash of x is minus sin x, f triple dash of x is minus cos x. Now can someone tell me what is the derivative of this again? The fourth derivative of x, if you calculate, minus of cos x differentiation is again sin x. And if you start differentiating from here, which means these 4 terms will keep appearing as sequence. Yes or no? Correct? 2. Because here it is sin x, the derivative of sin is cos, derivative of cos is minus sin, derivative of minus sin is minus cos. Once you calculate the derivative of minus cos, it again gives you sin x. Okay, means after every 4 terms, the things keep repeating each other. Okay, so at x is equal to 0, what are these values? at x is equal to 0, f of 0 is sine 0, which is equal to 0. F dash of 0 is cos 0, which is 1. F double dash of 0 minus sine 0, which is 0. And f fourth derivative of 0, which is minus cos 0, which is minus 1, of course. So which means this 0, 1, 0, minus 1, these things keep repeating actually. Okay. So if you add the expansion of sin x, so therefore sin x is equal to, now let's replace here f of 0. So sin 0 is 0. Then x into first derivative. So what is the first derivative value? 1. So 0 plus 1 into x minus a, which is x by 1 factorial, plus second derivative x square into f double dash of 0, 0 by 2 factorial, plus x cube into third derivative is, this is, sorry, the third derivative, this is not fourth, third. Then third derivative is minus 1 by 3 factorial. What about the fourth derivative? Again 0 by 4 factorial, and so on. This sequence will go. So if you simplify this result, you can see, first of all, there is no even powers of x, because x square, x power 4, all these coefficients will be 0. Okay. Then remaining with the coefficients of odd powers of x, there is 1 plus sign, and then there is a 1 minus sign. Similarly, again plus and minus. So if you simplify this, you will end up with x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial, and so on like this. Okay. So this is basically the expansion of sin x in terms of x actually. Clear to all of you? So please type in the chat box, is this clear? Did you all understand how did we get the expansion of sin x actually? Okay. The expansion of sin x about x equal to 0 is basically this. Okay. And since it's a polynomial function, you can see this is completely a polynomial. Then you can have the differentiation at as many times as you want. And that's how the differentiation is cos x. In continuity of f of x, f of a is not equal to limit. No, it should be equal definitely. Okay. That's how the continuity is defined mathematically. Fine. So let's see. Similarly, if you would have written for cos x, similarly, cos x is equal to 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial, and so on, of course. Okay, so this is x power 0 by 0 factorial, of course, and that's positive sign, then minus, plus, minus, so even powers keep fluctuating. Okay. So will this session be every day? Yeah, this session will be every day from Monday to Friday. Okay, and from 7 to 8:30. Clear? So let's see, this is cos x. Now can someone suggest me how you will get this series? Can someone tell me how will I get the value, or how will I get this expansion basically for cos x? Can someone tell me how would I get this expansion for cos x? The same procedure can I do? Yes or no? Like basically I write x minus a into by differentiating. Yeah, very good. One option is if you differentiate this with respect to x, you will get the expansion of cos x. Okay, because if you apply differentiation on both sides, what happens is, see, I'll show you here. On differentiating both sides, with respect to x, okay, on differentiating both sides with respect to x, this implies d by dx of sin x is cos x. Now derivative of x with respect to x, 1 minus derivative of x cube, 3x square, 3 cancels 3 factorial, 2 factorial times, so x square by 2 factorial plus this 5 into x power 4 by 5 into 4 factorial, so 5 gets cancelled, you have x power 4 by 4 factorial minus, similarly this becomes x power 6 by 6 factorial, and so on, which basically gives you this expansion. Derivative plus sign here, minus, okay, yeah, minus x power 6 by 6 factorial. Okay, so that's how you can get. Okay, or else you can basically follow the classical procedure, calculating first, second, third, fourth order derivatives, and that's also you can do. Now let's see, I'll give you some more expressions which could be helpful. E power x is 1 plus, if you expand again, you will get basically this expansion, summation x is equal to, sorry, n is equal to 0 to infinity x power n by n factorial. That's it. Okay, so this gives you basically the expansion for e power x. Okay, so if you run the summation, what happens? So if you take n equal to 0, x power 0 1 by 0 factorial 1 plus n equal to 1 gives you x power 1 by 1 factorial, x square by 2 factorial, and so on. This goes till infinity. Okay, so this, I'll just put an infinity sign here. So if you see, this is 1 plus x by 1 factorial plus x square by 2 factorial, and so on. Okay, so that's the expansion of e power x. So the differentiation of e power x is again e power x. You can show using this also. If you just differentiate both sides, you will again end up with the e power x expansion. So the derivative of e power x is e power x as well. Okay, then let's see one nice thing, of course. So some useful expansions which I'd like to give. Expansions which we'll again use during the Poisson distribution and all when we are doing probability, but some useful expansions. Okay, so let's check it up. First, 1 plus x whole power minus 1. Okay, so this is something like 1 minus x plus x square minus x cube plus x power 4 and so on infinity, but this is valid when mod x less than 1, of course. Okay, by using the geometric progression actually. Second, basically these are from the binomials. Again when mod x less than 1, of course. Okay, and you will see 1 plus x whole power minus 2 is 1 minus 2x. This is called AGP, arithmetic geometric progression, minus 4x cube plus 5x power 4 minus and so on infinity when mod x less than 1, of course. Okay, and fourth would be 1 minus x whole power minus 2, which is 1 plus 2x plus 3x square plus 4x cube plus 5x power 4. Okay, so that's basically the expansions which are helpful to you many times when you're doing calculations, especially once we start working out this Poisson distribution, and if you're trying to simplify the summations for mean, standard variance or standard deviation, these kind of things, these summations would be a lot helpful actually. Okay, clear? So let me give you one question. I hope it's clear to all of you till this point. Okay, so basically if you want to generate Taylor series of any function, this is the classical way to generate, which I have shown for sin x, and these expansions would be helpful to you in some general calculation times. Okay, so everyone please type in the chat box, is this okay to all of you till this point? Come on, please type in the chat box. Is this fine to each and every one of you till this point? Yes, okay. So if this is fine, then I'll ask you to solve a question maybe. So let's solve this question. Hello, solve this question. So it is an integer. So previous question answer is 2. Some of you, Agnika has said correct. Good. So for this question, it's an integer again. So you can enter in decimal, of course. There's a provision. So 122nd is, or 150 is what I'm giving. So think. So solve this question again. So S is equal to summation n equal to 0 to infinity n into alpha power n, of course, and mod alpha less than 1. The value of alpha is in the range of 0 to 1 such that S is equal to 2 alpha. So S is equal to 2 alpha, where mod alpha less than 1, the value of alpha in the range such that, I think this got repeated, maybe is 2 is dash. Okay, so this statement got repeated actually. I think people have copy pasted it twice, but of course. Okay, so this is the question. Then what is the value of alpha? Alpha cannot be 1, okay, because strictly alpha lies between 0 and 1. Okay, alpha is not 1. Okay, even if alpha is 1, this equation won't get satisfied. Come on, do this question. S is equal to 2 times of alpha, then what's the value of alpha? 8. Why 4? It's given, no? Clearly 0 is, alpha is lying in between 0 and 1. Then how can it be 4? 4 is lying in between 0 and 1. No? Come on, quick, faster. 0.29 maybe possible, because 0.29 is in between 0 and 1. Come on, last few seconds. Quick. Okay, so great. So let's solve this question. So first of all, what is S? That's the thing we have to worry about a bit. So S is equal to, so this expansion tells you S is equal to, so if you start with n equal to 0, this is like 0 into alpha power 0 plus 1 into alpha power 1, 2 into alpha square plus 3 into alpha cube, and so on. Okay, and obviously mod alpha is less than 1. Okay, so that's what they have given. So S is of course 2 alpha. So 2 alpha is what they have given you. S is equal to 2 alpha. Then this term is anyhow 0. This term can be straight away made 0. Then starting from the remaining terms, if you take an alpha common from the remaining terms, you have 1 plus 2 alpha plus 3 alpha square plus next term would be 4 alpha cube, and so on. And this is when mod alpha is less than 1 actually. Okay, so mod alpha is less than 1 of course. So this is when mod alpha is less than 1. Okay, so ultimately you can cancel this alpha and this alpha. So this tells you 2 is equal to, this expansion can be written as 1 minus alpha whole power minus 2, because obviously mod alpha is less than 1. So when mod alpha is less than 1, just now I have given you this expansion, 1 plus 2x plus 3x square plus 4x cube and so on, can be written as 1 minus x whole power minus 2. So this tells you 1 minus alpha whole square is equal to 1 by 2. Correct? So what about alpha? Alpha is equal to 1 minus 1 by root 2 comma 1 plus 1 by root 2. But clearly you can not consider this. This is wrong since it is given 0 less than alpha less than 1 obviously. Okay, so if this is 0 less than alpha less than 1, then ultimately alpha is equal to 1 minus 1 by root 2. So what is the value of this? 1 minus 1 by root 2. Let us take a calculator. So 1 minus 1 by square root of 2 actually. So 0.2928. 0.2928. So let's say if they have asked you to round off to 3 decimals, 0.293 would have been the actual answer. Okay, so that's it. 0.29. Yeah, of course. I think Suvarna, you have got this answer, 0.29. So the value of this is 0.29. You can round off. Fine. Is this clear to all of you? A very simple question, but of course you have to know a bit of this expansion, how to deal this expansion, and for which I have given you the data here in this part. Like this, you can see this expansion is what they have used, the fourth expansion. Okay, fine. So please type in the chat box, is this clear to all of you or not? I'll give you one more question, just to work it out. Normal in case of Poisson distributions and all, you'll get this summation. The value of summation n equal to 0 to infinity n into 1 by 2 whole power n is dash. Come on, do this question. Solve. Again, I'm giving you the answer. So 0.29 if you have entered, that would give you the correct answer. Good. Some of you have entered. One student entered correctly, but who is that student? So integer type. Again, 150 seconds. Start. Do this question. Summation. The value of this summation n equal to 0 to infinity n times of 1 by 2 whole power n is dash. Quick. Zero 0.5. Is it? No, I think answer is not 0.5. Would be definitely more than 0.5. Yeah. 100% is more than 0.5. Yeah, greater than 0.5. 2 possibly, maybe, correct. Let's give time to others as well to solve. Summation n equal to 0 to infinity n times 1 by 2 whole power n. Ashwini Kumar, 2, okay. Come on, do this question faster. Last few seconds. Some of you can solve this quick. So it is like the same question almost. Fine. Meanwhile, you try to enter this. So solution. See what you have. Sigma n is equal to 0 to infinity n times 1 by 2 whole power n. Okay. So if you start this summation, 0 into 1 by 2 whole power 0 plus 1 into 1 by 2 whole power 1 plus 2 into 1 by 2 whole square plus 3 into 1 by 2 whole cube plus and so on, of course. Okay, infinity. This goes till infinity because the summation is running from 0 to infinity. Now clearly this term is 0, the first term is 0. So in these cases, whenever you have n into some constant power n form, even if you start the summation from n equal to 0 or if you start the summation from n equal to 1, it doesn't matter, the answer would be same. Okay, because n equal to 0 term would give you 0. Okay, so please keep this in mind. Whenever you have things like this, the term corresponding to n equal to 0 doesn't matter. Okay, so that always gives you 0. Then when you take this 1 by 2 common, you eventually end up with 1 plus 2 times of 1 by 2 plus 3 times of 1 by 2 whole square plus and so on infinity, and clearly you know mod 1 by 2 is less than 1, of course. So if you simplify this, we have 1 by 2 into 1 minus x whole power minus 2, so which is 1 by 2 into 2 square, so the answer is 2. That's it. Okay, so because 1 minus 1 by 2 is 1 by 2, 1 by 2 whole power minus 2 is actually 2 square. Okay, so 1 by 2 into 2 square is 2. That's it. So correct answer is of course 2 actually here. So 2 is the actual answer. Good. 2/3 of you have done it correct. Ragnika, Subarna. I think only the first choice is taken in your case of Ashwini. Okay, so that's the reason. So let's move on to the next case where you have the coefficients. Okay, they ask you the coefficient of this. So let's say if I ask you the coefficient of x square in e power x plus x square expansion about x is equal to 0. So let's say you have this. Okay, about x is equal to 0 is dash. So let's see if I ask you this question in general. Now once I ask you this question, what you'll do is ultimately if you expand this function, so let's say f of x is equal to e power x plus x. Okay, so we know the coefficient of x square term, the coefficient of x square is f double dash of 0 by 2 factorial. Correct? Yes or no? So please type in the chat box. Can I say this? The coefficient of the x square term is going to be f double dash of 0 by 2 factorial. 2. Can I write it this way? So please type in the chat box. Can I write it this way? The coefficient of x power something is actually x minus a whole power n by n factorial. So ultimately I want the coefficient of x square. If I have the term only of x square, that means my a value is 0, so which is f double dash of 0 by 2 factorial. Okay, so please type in the chat box. Can I do this? Yes or no? Please type in the chat box. Can I write this? Yes. Now let's see. So what's the second derivative? Let us calculate. So f of x is equal to e power x plus x square. So this implies f dash of x is e power x plus x square into 1 plus 2x, obviously. Okay. Then let's see what is the f double dash of x. First function into derivative of second plus second function into derivative of first, which is x plus x square into, there's a square on the top of this. Okay, because one more 1 plus 2x will come, so this 1 plus 2x will have a 2 on the top of it. So at x is equal to 0, this implies f double dash of 0 is equal to, when you keep x is equal to 0 here, 0 plus 0 is 0, so e power 0 is 1 into 2 plus, when you put x equal to 0, this is 1 square into e power 0, so 2 plus 1, which is 3. Okay, so therefore coefficient of x square is 3 divided by 2 factorial, which is 3 by 2 is the actual coefficient. Okay, so the coefficient of x square term is going to be 1.5. 1.5. Okay, you can actually check this in one more way. How you can check this? Look, you have e power x plus x square function. This can be written as e power x into e power x square. True? So if this is written as e power x into e power x square, so first e power x 1 plus x by 1 factorial, x square by 2 factorial, x cube by 3 factorial, and so on, multiplied with e power x square expansion would be 1 plus x square by 1 factorial, x power 4 by 2 factorial, plus x power 6 by 3 factorial, and so on. Correct? It would go in this way. So that's how the two expansions goes up, right? So this is basically the e power x, and this is e power x square actually. Now if you want the coefficient of x square really, how do you get this? Multiplying this one with this x square gives you the coefficient of x square. So coefficient of x square is equal to, let us see how you will get the x square terms. So if you multiply this one with this x square, then ultimately you will get x square coefficient. So 1 into 1 by 1 factorial is 1 plus, again if you see, if you multiply this x square by 2 factorial term with this one, then also you will have a 1 by 2 factorial coefficient. Apart from this, if you multiply any other term with any other term in this second expansion, you will not get a coefficient of x square actually. So there are only two multiplications which gives you the coefficient of x square. One is multiplication of this constant with this x square by 1 factorial term, or this x square by 2 factorial term with this one. That's it. These are the only two possibilities. And if you add this, that's it. Okay, no need of complete differentiation and all. So this 3 by 2 can also be obtained in that way. Okay, any questions so far? Everyone, Sagnika, Subarna, Pranav, Ashwini, any one of you, do you have any questions? So please type in the chat box. Have any questions here till this point in the Taylor series? Yes or no? So please type in the chat box. Any doubts or anything? Because all this is a very basic and easy stuff, so I'm just going a bit quick. That's all. Okay. Then let's see. I'd like to give you one last thing here. The coefficient of x minus a whole power n in the expansion of f of x plus or minus g of x is x minus a, or basically you can see this is nth derivative of f at a by n factorial plus or minus nth derivative of g at a by n factorial respectively. Because obviously, like let's say in this case, instead of having multiplication here, if I had a plus in between, then ultimately the coefficient of x square in this expansion plus the coefficient of x square in this case. Okay, so that's how we would have got the answer. Okay, so this statement is again a very important. Few times they can ask you things from here. Okay, so please make a note of this step. Fine. So if these things are clear, then I want you to solve one question, actually the Lagrange's mean value theorem based question. After that, I'll start the concept of maxima and minima. Okay, so this question you can solve hopefully. And to solve this question, I'll give you some, say, 3 minutes time. Okay, so timeless poll, single choice, start. Okay, I'll set a timer for 3 minutes. Do this. The value of the function f of theta is given by this particular determinant, where theta belongs to pi by 6 comma pi by 3, and f dash of theta denote the derivative of f with respect to theta. Which of the following statement or statements is or are true? There exists theta belong to pi by 6 comma pi by 3 such that f dash of theta is 0. There exists theta belongs to pi by 6 comma pi by 3 such that f dash of theta not equal to 0. Come on, do this. Solve this question. I'm giving you 3 minutes to solve. Come on, a bit quick. Time is rolling up. Okay, last 1 minute. Fast bit. Last 10 seconds. Quick. Okay, I have stopped the poll. Fine. So first of all, tell me one thing. How many of you did not understand what to do? You have read the question and you didn't understand what to do. So how many of you have faced this situation? Solve the question, like you have read the question, but you didn't understand what to do. How many of you experienced this? Tell honestly. Everyone, or some of you? No? Okay, so check here. First of all, by looking at this question, told some things. Theta belongs to pi by 6 comma pi by 3. There exists theta belong to pi by 6 comma pi by 3 such that f dash of theta is equal to some value is what they have given, which means, so how to identify in the exam which concept is asked in this particular question? That's what I'm telling. So see here, you can see this statement. They told this f of theta, where theta belongs to pi by 6 comma pi by 3, so some interval is given. F dash of theta denote the derivative of f with respect to theta. Which of the following statement or statements is or are true actually here? Okay, so first statement, there exists theta belongs to this a comma b such that f dash of theta is equal to some value. Okay, so when they are talking about this theta which is lying in between this, undoubtedly they are talking about something which is in the interval, so we have to go for the mean value theorem. Okay, so let's see how we can do this. If we apply mean value theorem, given f of theta is equal to, f of theta is equal to, so sin cos tan, sin theta cos theta tan theta, sin pi by 6 cos pi by 6 and tan pi by 6, then sin pi by 3 cos pi by 3 and tan pi by 3 actually here. Okay, so this is your f of theta actually. Okay, so if this is your f of theta, ultimately if you expand this expansion, what you will get, this expansion will go something like sin theta into this cos pi by 6 tan pi by 3 minus cos pi by 3 into tan pi by 6, which is basically some constant k1 times sin theta plus constant k2 times cos theta plus constant k3 times tan theta. This is what you will get. Okay, and theta is lying in between pi by 6 to pi by 3. So ultimately if theta is lying between pi by 6 to pi by 3, at each and every point in that interval, this complete function is differentiable. Yes or no? Correct? Sin is differentiable at any value of theta, cos is differentiable at any value of theta, tan is definitely differentiable in the interval pi by 6 to pi by 3 because pi by 2 is outside that interval. Okay, so that's why this complete function f of theta is differentiable at each and every point in pi by 6 to pi by 3. Yes or no? So this is differentiable, differentiable in pi by 6 to pi by 3. Yes, is that clear to all of you? First of all, can you all get convinced that this function has derivative definitely at each and every point in this domain, in that interval pi by 6 to pi by 3? Yes or no? Please type in the chat box, every one of you. If there is pi by 2 involved in this interval, then even at that point it would have not been differentiable because there is involvement of tan, but within this given interval it is differentiable, right? Now let's see. Therefore, by Lagrange's mean value theorem, there exists at least one value of theta such that f dash of theta is equal to f of b minus f of a by b minus a, of course. Okay, so pi by 3 minus pi by 6. So now the main point is calculating this f of pi by 3. Okay, so to calculate this f of pi by 3, you need this k1, k2, k3. Yes or no? Yes. To calculate this f of pi by 3, you need this k1, k2, k3 constant values. Yes or no? Come on, tell me. Because obviously if you want to calculate the functional value, you need this constant, right? K1, K2 and K3. Do you need this or not? Yes, but actually we need not know what are the values of K1, K2, K3. Okay, the reason is, see, if you put f of pi by 3 here, so if you put theta is equal to pi by 3 in this expansion, when you put theta equal to pi by 3, this expansion becomes pi by 3 is equal to, so when you put theta equal to pi by 3, the first term becomes sin pi by 3, cos pi by 3, tan pi by 3. Okay, so when you put theta is equal to pi by 3, the first term and the third term becomes identical, correct? If first term and third term becomes identical, what is the value of f of pi by 3? Please tell me. When you are putting theta equal to pi by 3 in this particular determinant, the first and third rows of the determinant are becoming identical. And if two rows of a determinant are identical, since linear algebra you have already finished, so what's the value in such case? 0. Okay, so many times people waste their time in calculating the values of k1, k2, k3, but that's not needed. Okay, so f of pi by 3 is equal to 0. Similarly, f of pi by 6 is also 0 because when you put theta equal to pi by 6, first and second row become identical. Okay, so okay, so that's it. So therefore, there exists at least one value of theta such that this f dash of theta is 0, 2. So first statement is correct 100%. So there exists theta in this interval such that f dash of theta is equal to 0, 2. This is correct. Then in this interval, so second statement, let's understand second statement. So theta belongs to pi by 6 comma pi by 3, of course. Then if you differentiate f dash of theta is something like k1 cos theta minus k2 sin theta plus k3 secant square theta. Now depending on k1, k2, k3 values, it has some finite number of solutions. Yes or no? Basically it's not like this identity is 0, correct? Or basically in this, say what I want to is not equal to 0 by default, okay, which means this is not an identity which always gives you 0, of course, correct? There could be some solutions of theta which could satisfy this equation, which you can say confidently by using mean value theorem. But at the same time, in pi by 6 to pi by 3, there are infinite number of points. Definitely this is not 0 at all the points, which means definitely there would have been some points where derivative is not equal to 0, correct? See, basically I have told you f dash of c is equal to 0. There exists theta belongs to this interval a comma b such that this f dash of c is equal to 0. So there are few values of theta which satisfy this equation, but in this interval there are actually infinite number of points, which means out of which if few values of theta are satisfying this equation, then definitely there are other values of theta which are not satisfying this equation as well. Yes or no? True? So please type in the chat box. Can you all get this? This derivative equal to 0 is not an identity, okay? Depending on the values of k1, k2, k3, it has some finite number of values of theta, that's it, okay? It's not like at every value it is 0, but there exist values of theta such that it is 0. At the same time, there exist values of theta at which this is not equal to 0 as well. So ultimately, statement is also a correct statement. So both 1 and 2 are correct actually here. Okay. So both statement 1 and statement 2 are correct options. Okay. So that's the advantage of basically the knowing LMVT solve these kind of questions actually here. Okay. So let's see now the concept of maxima and minima in single variables. Okay. So first of all, before going for the concept of maxima and minima, I want to ask you one thing. So if you have a function like this, so this is xy axis, which normally you take here. So let's say, for example, if you have a maximum like this, something like this, okay, so there is some function which gave you some random wave, let's say. In such case, if you want to have this peak, for example, okay, so let's say this is some maximum value. If you want to have that peak, in general, if you want to have maximum, how will you get a maximum here? The function y equal to f of x, you see this is the function y is equal to f of x. Then if you plot this point x is equal to a, then what happens? Till x is equal to a, the function keeps increasing, and then after it starts decreasing, correct? Means till to the left of this point a, if you keep increasing the values of x, this function keeps increasing, and once it crosses that point, if you further increase the value of x from this point to this point, the function value starts decreasing again. Okay, if you want to have a maximum, the function at that point should change from increasing to decreasing, only then you will get a maximum. Similarly, if you want to have a minimum, ultimately what happens? If this is x is equal to b, then ultimately the function should keep decreasing, and then after this point it should start increasing, only then you will experience a minimum. So forget about the maths, okay, we'll see the equations and all, but physically if you want to have a maximum, the function should be increasing and then it should start going down. So therefore the function should change its nature from maximum from increasing to decreasing actually to have a maximum. Similar to have minimum, the function should change its nature from decreasing to increasing, then you have a minimum. Yes, is this clear to all of you from the graph? We'll see the mathematical equations, but Is this clear to all of you till this point? Okay. Fine. So is this clear to each and everyone? Then let's see if this is clear. Let's see what we can get actually. Well, the function to have a maximum, it should change its nature. It should change its nature from increasing to decreasing, from increasing to decreasing at that point of extrema, at that point of extrema actually. Okay, so normally this is called the extrema, and this is the point where the function has got its peak. So obviously highest peak or the lowest peak, it doesn't matter. So at the point of extrema, it should change from increasing to decreasing, of course. Okay, now first of all, so here I have done a graph simply so you can understand it is increasing and then it is decreasing. Okay, but mathematically how do you identify whether at a given point a function is increasing or decreasing? Okay, so that's why it's important to learn the concept of decreasing and increasing functions. Decreasing and increasing functions. Okay, so decreasing and increasing functions. So let's see this case of decreasing and increasing functions. A function f of x is said to be increasing, is said to be increasing at the point x naught if at the point x is equal to x naught, at the point x is equal to x naught, if f dash of x naught is greater than or equal to 0, and strictly increasing if f dash of x naught is greater than 0 strictly. Okay, so if there is an equality sign, you generally call it increasing, but if it has to strictly increase, okay, then the derivative has to be positive. So basically how we get this, look, the meaning of an increasing function in general is horizon x, y. So as you keep increasing x, the function value should also increase. Okay, so you can see here in this case, so what happens is when this value is x1, and obviously this is f of x1. Now as x increases, so let's say you move from this point to say some this point, x is equal to x2, so you have f of x2, of course. So as x is increasing, then f of x should also definitely increase in this case. Okay, so you can see as x increases, as x increases, f of x also increases. Okay, so this implies if x1 and x2 are very close, so let's say at this particular point x0, so you take this point to be x0, and if you move slightly in any domain, if you see, consider f of x2 minus f of x1 by x2 minus x1. Okay, so x2 minus x1. So when you take this f of x2 minus f of x1, can someone tell me this value is positive or negative? So type in the chat box f of x2 minus f of x1 by x2 minus x1. Is this going to be positive or negative? Just look at the graph and tell me. x2 minus x1, f of x2 minus f of x1. So what's going to be this value? Come on, quick. That value is positive or negative? This fraction. What's going to be that value? It's positive or negative? positive, right? Because clearly if x2 is greater than x1, f of x2 is also greater than f of x1, obviously. Okay, so this is, yeah, of course it is positive. So this implies if you take any point at any condition, and if you move slightly away from that point, ultimately the function value also increases. Okay, then similarly for decreasing functions, for a function decreasing, similarly for a function decreasing at x equal to x naught, f dash of x naught is going to be negative, okay, or equal to 0, and strictly decreasing if f dash of x naught is strictly less than 0, of course. Okay, so just the converse of this. Okay, sorry, this is, yeah, okay, so this is just the converse. Okay, and you could see one thing, if f dash of x naught is less than 0, obviously it is decreasing, and there is something called monotonic functions. So what is the meaning of monotonic function? Let's see. The function exhibit a single nature, either increasing or decreasing throughout the real plane. Okay, so if a function exhibits a single nature, or if a function is increasing, is either increasing or decreasing throughout the domain, or throughout the domain, of course the domain can be infinite, then the function is said to be monotonic in nature. Is said to be monotonic in nature. Okay, so that functions are said to be monotonic in nature. Fine, so let's see then example again. If you look at e power x, okay, so if you take this function, then I hope I have given you the graph of e power x. So if you look at the graph of e power x, origin x, y, and obviously if you slightly extend this, then let's see, the graph of this function is something like this. Okay, in fact it goes much steeper, just for the diagram purpose I am showing you. Then from minus infinity to infinity, at any point if you choose an x, like let's say maybe you choose an x somewhere here, at any point you choose x. Now if you slightly increase your x, is there any point where your f of x will decrease? Is there any point in this complete real plane where at any point if you slightly increase x, your f of x will decrease? Is there any single point at least of such type where if x is increasing, then f of x is decreasing? Can you find any point? No, obviously, correct. There is not even a single point where when you are increasing x, f of x actually decreases. At each and every point, like you choose any point in this real axis, as you keep increasing x at any given point, if you give a small perturbation in x in the positive direction, ultimately f of x keeps increasing. Okay, so therefore f of x equal to e power x, if you see this function is increasing all over the real plane, all over the real axis. And obviously if you check this, f dash of x is equal to e power x actually, and this is 0 for all x belongs to real numbers. Okay, so there is no value of x where e power x is negative, of course. Okay, so you can see e is a positive number, so e power x is of course positive for any value of x actually. Okay, so that's why this f dash of x is positive. Similarly, if you take, so you can say therefore f of x is equal to e power x is monotonically increasing. Okay, so this function is monotonically increasing. Clear? So because from minus infinity to infinity, you cannot find a value where when you increase x, f of x decreases. Okay, there is no such situation. Similarly, if you have f of x is equal to e power minus x, then you know, all of you might have seen the graph again. Maybe I'll plot here. So if you plot y equal to e power minus x, then let's see what happens. This is 0, x, y here. Okay, so this is the graph of y is equal to e power minus x, and this value is 1, of course, at x equal to 0. Then at this point, you see, at any point on the real plane, if you start, okay, fine. So let's see. Then you can check at any point you take a value of x, and if you slightly move the positive direction, ultimately f of x decreases. Okay, there is not even a single point where when you increase x, f of x also increases. Okay, so and if you calculate f dash of x, this is minus e power minus x, and this is negative because of this minus sign for all x belongs to the real plane. Okay, so therefore you can see f of x is equal to e power minus x is decreasing, is monotonically decreasing, is monotonically decreasing, of course. Okay, so that's monotonically decreasing. Now, but a few cases it do not happen this way, like f of x is equal to sin x. If you take this, then what happens if you plot the graph of sin x, which again I have given you. If you plot the graph of sin x, so let's see, this is 0, so let's say this limit is 1 first, and this is pi. Then you can see if you plot the graph of sin x, so something like this. Okay, then if this value is pi by 2, if this value is pi by 2, then within this domain 0 to pi by 2, what happens? Within the domain 0 to pi by 2, as x is increasing, your f of x is also increasing, and beyond pi by 2, from pi by 2 to pi, as x is increasing, this f of x is actually decreasing. Okay, so which means this function behaves as increasing from the domain 0 to pi by 2, and then after it behaves like decreasing function from pi by 2 to pi actually. Okay, even if you calculate the derivative equal to cos x, so cos x is positive in 0 comma pi by 2, and cos x is negative in pi by 2 comma pi, of course. Okay, so clearly you can see, since this because obviously from pi by 2 to pi it enters the second quadrant, and in the second quadrant cos is negative, so obviously once it crosses pi by 2, the function value keeps decreasing as your x keeps increasing up. Okay, so that's how checking the sign of the derivative is a very, very important point. Clear? So the derivative sign should change from basically from negative to positive if you want to have a from positive to negative if you want to have a maximum. Similarly, for having a minimum, it should change from negative to positive again. Okay, so the idea here is you will experience a maximum when the derivative changes its sign. Now observe one thing, in this part the derivative is positive, and in this part pi by 2 to pi the derivative is negative. So exactly at this point of maximum or minimum, what should be the value of the differentiation? Please tell me. You have seen, if you want to have a maximum, the function should change from increasing to decreasing. So during the increasing, the function's derivative is positive, and during decreasing, the function's derivative is negative. So the derivative is changing its sign from positive to negative in order to have a maximum. So exactly at this point where there is a maximum, what should be the value of derivative? Come on, quick. Here, correct? So therefore the derivative has to be 0. But this derivative being 0 is just a necessary condition but not a sufficient. Okay, so first of all, if you want to have either maximum or minimum, at that point the derivative is 0 definitely. But if derivative is 0, the function need not have a maximum or minimum, okay, which we'll see basically in the tomorrow's class, because it's already 8:30, 1.5 hour we have finished. We'll stop it here for today, okay, because again it's the first class and this is all a bit of easy stuff. So I'm just quickly going to the single variable calculus so that we can start multivariable, okay, in upcoming 2-3 classes maybe. Fine. Okay, so I hope you got the idea from a bit of graphs and all the derivatives each and everything. So we'll work out some questions like in every class, like how we have done in today, and that's how we progress. Okay, so of course, so these are the solved examples we have done today. Then in today's class we focused majority on revision of past lectures. Then we talked about Taylor series in single variable, and of course in multivariable calculus I'll teach you single Taylor series in 2 variables as well. Then we talked about decreasing and increasing function, which builds up the concept of maxima and minima. So these are the topics which we have covered in a broad sense. Will you share the PDF? Yeah, I'll share the PDF. Even the link for the PDF will be in the description of this video. Okay. So please give some tips for 𝐂𝐸. To be frank, like majority of the people score good in technical subjects. Okay, maths is slightly a bit one step ahead of compared to the normal papers. So there you have to be little careful. Maths would be slightly more tricky in 𝐂𝐸 paper. Fine then. So thank you all. We'll meet again on 7 PM tomorrow. So basically we'll meet at 7 PM tomorrow. We'll start the discussion of maxima and minima and we'll slowly move on to integration. Okay. So we'll see. Right now we are talking about the differentiation and applications of derivatives, these things. So we'll slowly move on to integration in tomorrow. Okay. So that's it. Thank you all. I hope it's clear. If you have any questions, you can ask me. 1.5 hours went very quickly, right? Many of us didn't recognize it's already 1.5 hours. So fine then. Thank you all. Okay. So we'll meet again on tomorrow at 7 PM and we'll talk about maxima. Okay. Fine. All of you. Okay. If you have any questions, you can ask me, or else it's fine. Okay, no more questions. Fine then. Thank you all. Take care. We'll meet tomorrow at 7.